Okay, good morning, students. How are you doing this morning? All right, trying this for a second time. Good morning, students. How are you doing today?
Good morning, sir. I'm doing
Hello.
fine.
Good morning. Are you hearing me?
Yes, sir, we're hearing.
Okay. Wow. I thought I was here alone. Well, I was, but then I saw you joining Danae, and then it appears as if we have a new student, but she's not answering me. Good morning, Amanda. All right, Danae. I'm just gonna wait a few more minutes to see if anybody else will join you, Danae. That's okay with you?
Yes, sir, no problem.
All right, cool.
Morning, sir.
Good morning. How are you?
I am tired. How are
Oh,
you? Sir Karen says she's having internet issues, so she'll soon log on.
okay. All right, no problem. All right. So Donnie has been here. I saw a new student, Amanda.
Here's
So I
my
was wait.
first class.
I know it's your first class, so I was actually waiting on Colin it and Kerry because they were here last week. Kerry, Colin it and Donnie were here. But all right. I will just wait a few more minutes, like I like no more than 5 minutes, because I need to talk to you guys. The class looks very small, but let us see. I'm gonna wait 5 more minutes, just five more minutes. I'm actually up. I've been up and waiting for the class, but five more minutes. All right.
All right, sir.
Mm-hmm. All right, guys. I must start. Can you hear me?
Yes, sir.
Yes, sir.
All right, so let me just get um, on with some housekeeping matters before uh, we get going. So Lori, the one Kerry seems to be your friend. So Kerry will tell you that last week Mr. Shant only had class for 2 hours. Well, 2 hours and a little bit, about 1.5 hours with last week, because we are expecting more students to join the class. And we are awaiting those students who are coming in from their CSEC results who will join us. So, right. So, we will still be meeting, but we're not going to meet to have our regular scheduled 4 hour classes. All right. So, when you hear me say that I'm finishing before 12 o'clock today, I don't want you to, feel a way to say that I'm shortchanging the other students would have agreed, right, Donnie? Okay, Donnie not supporting me. But the other students would have agreed based on what I explained to them last class, of the challenges that we are facing. So, um, so today again, I will end class around about 10 o'clock. And reason being, I don't want to move way too fast with you, but I don't want to not do anything with you if you follow what I'm saying. You don't have to worry. We will be able to make up the lost time. I guarantee you with that. And I can say to you that more information will follow. The institution will address the students in the town hall meeting on the matters that are developing. So just to set that out, we created a WhatsApp group. I'm not sure if you're added to it just yet, Kerry, but I mean, Laurie, but we created a
Yes,
WhatsApp
sir. I'm
group.
not added. Who's the
So,
admin?
I'm not sure, Oh, Coordinate is the admin. So, Foundation 3, Coordinate is the admin. So, we will, as soon as she comes, I will, I will definitely ask her to,
The admin.
yeah, man. So you don't have to worry about it because since um since Kerry is your friend, I can, if Colin does not turn up today, I can send Colin a message, then I can ask Kerry to give me your information. Is this what I'm saying? So it is that we can get
Yes, sir.
connected. All right, good. All right, so
Thank you.
no problem, honey. So last class, what we did was to look at the laws of indices. Now, Laurie, this is what I'm talking about, and I'm not in any way, shape, or form blaming you, but I'm just going to give you an example. So if you feel a way, I'm going to apologize even before I say what I'm saying. So it's like how you weren't here last week, Laurie,
Yes.
and in order for me to move on, it don't make sense. I move on with Daniel alone, and you are going to sit in a class very lost. I will have to do a quick revision of what I did last week. You follow my scenario?
Yes, sir. No
It's going to
problem.
be, right. It's going to be the same thing when the additional students join the class. So it is important for the lecturer to share information with the students so that the students can understand where we're coming from. So that is the dilemma that we're in, and we're not the ones alone. All the institutions are in that same dilemma. So Donnie not talk to me today. What one? You hungry?
Everybody's sleeping, so I can't really make so much night.
It's true. Because I don't hear me talking very quiet myself. Because what I recognize is that when the when the host kind of quiet, so your voice projects.
Yes, sir.
So it's that's not perfectly understood. So I am actually here whispering myself. All right. Okay, so Donnie saw this already. Kerry, Laurie. Why am I calling it Kerry Laurie? Jeez, Donnie saw this already, Laurie. So um, she will look on while her loved ones are still asleep. And then you and I will have a conversation. Now, I'm going to do the same thing that I did to them. What I did with them last week is to project it and give them an opportunity to read for themselves. And then when they would have read it, then I go through. So, Laurie, just let me know when you want to scroll up. You have 3 laws. There are 9 of them. You have 3 laws so far. Take your time and read through. You don't have to worry about it. I will send you these notes. So don't even spend time to write per se. When I send you the notes, you can write. Just take some time and just read through. Let me know when to scroll. And then I will go through the explanation with you. All right, Laurie? Laurie, you hearing me?
Yes, sir. I'm here. I just went to get my book.
Okay, what I was saying to you is what I did with the students last week is have them read through the laws of indices first, and then I'll go through the explanation. So I want you to take some time to read through for yourselves. You don't necessarily need to write it.
Yes.
No, just read through, and then I will go through the laws. I'm going to send you these notes so you can write it up at that time.
Okay, sir. Sir, there's something below that. Sir, why number 7 look confusing, so
Listen to me. Oh, I leave number 7 alone here, Laurie. In Jesus' name. Oh, I leave number 7 alone. All right. Yes, I would agree with you. So number 7 follows from number 6. But number 7, what I did with those many steps is just to show you the explanation in a stepwise manner. So let us look at number 6. Number 6 says the nth root of A, the nth root of A. Now, when you say the nth root of A, it is saying to us that we are naming that stuff based on the number that is in the sleeve of the square root sign. So you recognize that n is in the sleeve of the square root sign. So it is going to be called the nth root of A. So if you look here, you will see that it has the n, as I was saying, in the sleeve. I cannot change it because something was on the screen. So the sleeve, in the sleeve right here, I have an n. So that's how I'm going to be naming my square root. It's going to be called the nth root of A, right? Now, normally you'll have a 2 inside here, and that's why it's called the square root. So the naming of this comes from what is inside of the sleeve. So had this been a 3, it would have been the cube root. If it was a 4, it would have been the 4th root, and 5th root, the 5th root, 5th root, come on, Shan, 5th root. If it was a 6, it would have been the 6th root, right? So this is going to be the nth root of A. Now, when you write the nth root of A, what we're doing is reciprocating whatsoever is in the sleeve of the square root sign, and then it becomes the power of what is under the square root sign. So the nth root of A is going to be the same thing as A raised to the 1 over n. So how we get the 1 over n again? I reciprocated what is inside the sleeve of the square root sign. All right, so this one is the same thing, but it's just that this one here now, under the term under the square root sign is being raised to a power other than 1, because here the term is being raised to 1. So anytime you don't see a power, you're going to assume that it is 1. So this one is being raised to 1. The 1 here is raised to n. So how you know the 1 here raised to 1? See it right up here. So again, the 1 here. The 1 here now is raised to n. But the same explanation I gave you from here, whatsoever is in the sleeve of the square root sign is going to be reciprocated and multiplied by the power of what is under here. So let's go. This is going to be a to the n. See, right here said a to the n, and it's being multiplied by the to the power. It's going to be raised to the power rather. It's going to be raised to the power. So see, you know, n. So it's going to be raised to 1 over n because we're reciprocating it. See here, 1 over n. But if you look at this law says a to the n raised to the nth power is equal to a to the n. So it means that when you have one base raised to a power, raised to another power, you have multiplied the 2 powers. Watch this. You have one base raised to a power, raised to another power, you have multiplied in 2 powers. So in the next step, I'm showing you how it is that within the multiplication of the powers, this n is the same thing as m over 1. And then when I'm multiplying 2 fractions, I multiply the numerator by the numerator. So if you look at how I'm writing it again to show you now, because I want it to be in line. This really wasn't in line, so I want to show you in line. M times 1 is m, and 1 times n is n. So I could have moved directly from here right up to here to show you what is really happening. All right. So the nth root of a to the n is going to be equal to a to the m over n. See here? A to the m over n. Remember, you can skip 1, 2, 3, and jump directly from here to here. How can you do that, sir? Watch the sequence. A is being raised to m. Whatsoever is in the sleeve of the square root sign will not always be in the denominator. G's on T, sir, see, because this is in the sleeve of the denominator of the square root sign here, sir, and it's in the denominator. This n is in the sleeve, and it is in the denominator. So yes, sir, I understand. All right, sir. So it's going to be a to the m over n. a to the m over n. All right. So that's what that one is. So it's not all that bad. Is it clear now, Lori?
Yes. Sir, yes, sir, I understand.
Amanda keeps joining the class and leaving. I don't know if she's trying to find her class, but she keeps logging on and then dropping off. Or maybe she's having internet connectivity issues. But I would love to meet with her so that I can tell her the things that are happening. So I don't want anybody to feel disenfranchised. So come up class and I get half a time and the pay school here and friends, trust me, you don't have to worry. If you know Mr. Shandway, Mr. Shand don't teach you 45 hours for a 45-hour course. Case in point, I had some calculus 2 students in the summer. And there was a very weak student in the class, and every day that got sent, the young man asked me, "Sir, can we meet tomorrow? Sir, meet after I come from church. I eat a solid dinner. Sir, we can meet at 6 o'clock." And I said, Lord, if a student is asking for class, it means that the student needs help. I'm going to pray for strength. Guys, I had a class Friday night. My foundation 3 class Friday night. Saturday morning, I had them. Sunday, I had business calculus. Monday, I went back to the calculus 2. Tuesday, I went to calculus 2. Wednesday, I went to calculus 2. Thursday, the exam was 1 o'clock. Thursday morning from 10 o'clock, they had me in class up to minutes before the exam. But you know what I'm happy about? They all passed the exam, and this is what I feel good about it. I love when I teach and students can go and reproduce. So I'm not worried about you guys. I'm very confident that you will do the very same thing. All right, Laurie, I can stop reading because them two are easy. Anything raised to the power of 0 is 1, and anything raised to the first power is it itself. All right? So anything raised to the power of 0 is 1. So let us start there. In the explanation, I've explained 2 of them already, 6 and 7. Then actually 3, a to the n raised to the n is equal to a to the n. So let's just go. So anything raised to the power of 0 is 1. Anything at all. Once I raise it to the power of 0, the result is going to be 1. Anything raised to the first number remains the same, is itself. Right? And did that already. And I also did 4 already, so let's look at 5. What 5 says is that when I'm multiplying and the bases are different, this is one basis A and the other basis B, but the powers are the same, I'm going to be multiplying the bases and put back the power. Watch it. A times B, and then I put it in parentheses, and I put it to the n. And must put it in parentheses, because if I only put AB to the n, it means is that only B alone is going to be raised to the n power and not A. So I have to put everything into parentheses. All right, and then raise it to the n. In this case, so look at what is happening. A to the n multiplied by B to the n. I'm going to be multiplying A and B together and then put back the power since the powers are the same. We did 4. Let us go to 321. 321 is so very useful. Oh my goodness. I was teaching another class this week on Thursday night, and I had to come into your notes and copy something from your notes into their notes because these principles are so important. And let me just stop and say it here. When you move to business calculus, you are going to see that all of what it is that we're doing here becomes very important. Very, very important. You can not learn this because when you go to business calculus, you are going to be lost. So I'm going to ask you to pay special attention to what is happening here, especially the one here, cheese and fodder. This one come like cell phone and salt and water. Very plentiful. A to the negative n is going to be equal to 1 over a to the positive m. So when you have a base raised to a negative index or a negative power or a negative exponent, all of those words are synonymous. I can say index, I can say power, I can say exponents, right? When I have a base raised to one of those negative things, in order for me to get the power to be positive, I'm going to reciprocate, meaning I'm going to put 1 over the whole other something here. So you notice this is a to the negative m. I try to put a little color to it so that you can see what is happening. A to the negative m is now going to be equals to 1 over a to the positive m. All right. Now, when I'm dividing and the bases are the same, it's going to be the numerator power minus the denominator power. Numerator power minus the denominator power. A to the n minus n. And the top one says when I'm multiplying and the bases are the same, I just go ahead and simply add the powers. Just go ahead and simply add the powers. Simply just add the powers. All right. So as I said before, very important. One of the things that I do is I send these to students, and I'm going to tell you why I send to students. Because these laws, as I said before, guys, you are all business students. And as someone who teaches business calculus, I know the challenges that I face when students come to the business calculus class, not having a firm and strong position with pre-calculus. The ones who come in very strong with pre-calculus, trust me, generally pass the course with ease. The ones who come in barely understanding, they struggle to business calculus, and sometimes they end up failing. So I'm going to say to you, be careful, be forewarned so that you can not fall into that category. It's really not difficult. And one of the things that I am personally going to be guaranteeing you is if you follow me closely, you're not having a problem. I'm not asking you to buy a textbook. I don't need for you to buy a textbook. You're paying your school fee. I will source the necessary information for you and present to you in class. Plus, you have your online textbook, Read Editorsoft. So, Lori, I know you're not yet on Editor. I'll get your information of you to put you on Editorsoft, right? So, I will research the different areas, the topics, questions. Your responsibility as students is to go to Editorsoft. When you go to Editorsoft, you are going to be thank you, Lord, I need to do this more. You're going to go to Editorsoft and you are going to be reading your tutorials, which is your online textbook. And I'm going to tell you what comes to mind just now, which is I was thanking the Lord. So I normally say to students, send me to my detriment because my phone is full and can't take a message. The other day I was on the bed and trying to clear up some stuff because I keep saying to students, yours is a responsibility to go and find past papers for the course. And when you find the past papers, you can post past papers in the group so that each one helps somebody. So Danny will find a past paper or 2 or 3. Lori will find a couple. And if it's not the same, you post it in the group so that we have a series of past papers. Now let me tell you why it's important. Mr. Shand will be teaching you and we'll be doing the past paper questions as we go along. So like we had finished doing laws of indices last week on Lori. I will then go into the past papers and find a few questions and do it, and then move on to the other topic. So after each topic, I'll do that. Now, what I'm going to do, I was thanking the Lord, is that as soon as I get those past papers into the WhatsApp group, I'm going to copy those past papers into your Editorsoft so that you always have those, so that I can delete them from my phone to free up some space. One of the things I should tell you, Laurie, is that, and I'm just remembering, so if I sound distracted, it's because I'm on my phone. I have a YouTube channel that I post all my recordings in for the class.
Yes, sir. Can you put the link in the chat?
I am going to do that. Matter of fact, I don't even put the link in the chat. So what I'm going to do, I'm going to get you added to the platform first. I mean, to the Dropbox, to WhatsApp first, and then I'm going to
Sir, Editorsoft is something that you will have. I will have to download in order to access.
No, dearest. Anywhere at all you have Wi-Fi and internet access, you can go ahead and do your stuff.
Okay,
you
so,
don't
so
have to.
I just Google Edicosoft and take it from there.
Right. All right, so I just remember that I had a class on Thursday and I uploaded their work to the YouTube channel, but somehow it's not showing in the stream, which is what happened to me the last time. Anyhow, I didn't upload anything for the Foundation 3 last week because last week we were doing just like I won't upload anything for today because we sat and we waited for about half an hour or maybe 35 minutes. So you may have 35 minutes of dead air, then all the stuff we talked about, it is for stuff and so forth. So it's not really much me per se. So I won't upload this one. I never uploaded last week because we did a lot of housekeeping like I'm doing now again. And again, Laurie, you see, every time a student comes to class, they will need to know this information. So I will have to stop and say, there's a YouTube channel, there's Editorsoft, let's get started, support and so on. All right. So just to let you know, I need to log on the computer to see if I can find those stuff. Let us look at this example. Let us look at this example just to show you what was happening here with what it is that we just looked at. So you will begin that question that says evaluate the following. Now, so the question is in blue. The question is in blue. Yeah, I was wondering why I have it like that. Should I just put it? Let me just. I don't have the layout of now. Of the work and put. So the question is in blue. The question is in blue. So the question is asking to evaluate the following. So it means that there are many questions, at least 2 questions. So the question is 3 to the 2nd power times 3 to the 6th power. 3 to the 2nd power times 3 to the 6th power over 9 squares. So because this one here is in a base 3, remember, this here is the base, and what it is raised to, as I said before, is called as the power, the exponent, or the index. I can say powers, I can say exponents, but when I'm pluralizing index, I have to call it indices. All right, I have to call it indices. Now, just like we call it matrices, right? So I have to call it indices. All right, so let's go. So because my base here is in 3 for this one, and my base here is also in 3, and I look at 9 and I recognize that I can write 9 as a base 3 into 9. Right, okay, sorry, I did it in stages. So I did the numerator first. So let me just hold it, stick with what I have. So because I'm multiplying and the bases are the same, I'm adding my powers here. So the bases are the same, so I'm using the first law that we learned, a to the n multiplied by a to the n is equal to a to the mn. So for what is happening? It's 3 raised to the 2 plus 6. Because I'm multiplying and the bases are the same, I am doing this. All right. You know what I have to do? Let me just show you something visually. Um, 3 times 3 dot copy down paste. I'm trying to show you something pictorially, and you'll find me do this ever so often. So Amanda, not Amanda, what am I talking about? Dummy, when I send you the notes, it means that I will forever continue sending this stuff because it's very important for me to do that. Just give me half a minute for the screenshot of this thing, please.
Sarah, where you gone?
When you write this, mommy, I come. I mean, I'll leave you, man. No, man, I'm saying that I'm right here. I'm not leaving you. I'm coming. Just give me 2 seconds. All right. Lori, Colin, it has just joined. So do me a favor, Lori. Just drop your number in the chat window, please, and then ask Colin it to just pick it up and add it to the group right now, please, dearest. And Colin it, I'm not sure if you're at work and can't speak, but if you're hearing me, Lori is a new addition to the class. Can you just add her to the WhatsApp group, please? Thank you. Thank you. Thank you. 6, 1, 2, 3, 4, 5, 6. All right, Lori. So I hear you loud and clear. Are we certain? I am right here, always here, will never leave you. All right,
Okay, sir.
let's go, Lori. Move. You see, oh, come on. I still have to go back again. Equals 3 to 8 power. And I shall use a nicer color today. That nice color is going to be pretty color. All right, so look at what I'm showing you now. Ouch, Lori. Is when I have 3 to the 2nd power multiplied by 3 to the 6th power. This is it. 3 to the second power is 3 times 3. Can you see that? And 3 to the sixth power is 3 times 3, 6 times. So that's 1 times 2, 3, 4, 5, 6. So 3 to the 3 squares is 3 times 3 because there's 2 3's up there. And this multiplication sign is this multiplication sign here. And 3 to the 6 means that I multiply 3 times 3 times 3, 6 times. So it's 1, 2, 3, 4, 5, 6. So when I'm doing the multiplication now, as I said to you, we're going to add the powers. How many 3's do I have in total? 1, 2, 3, 4, 5, 6, 7, 8. So that's how I get my 3 to the 8. See to yourself? 3 to the 8. And it's over 9 squares, right? So 9 squares is the same thing as, because I can break up 9 into 3 squares, I'm going to break up this 9 into 3 squares. So that's why I color coded it. So I'm going to have 9 is the same thing as 3 squares. But watch it. Don't get jumping off, because this 3 squares, remember the 9 is being raised to a second power. So this is going to be raised to the second power here. And the law that says a to the n, see it right to yourself, a to the n raised to the nth power is a to the n. So that means I'm going to multiply this 2 by this 2 to give me 4. So I'm going to have 3 to the 8 over 4. Now, remember also, when I'm dividing and the bases are the same, it's the numerator power minus the denominator power. So because the bases are the same here in terms of 3, I'm going to say now 8 minus 4. And of course, that is going to give me 4. So my answer is going to be 3 to the 4th power. Is that understood, Laurie?
Yes, sir.
All right, good job. Now, the others would have made an attempt to this one already, Laurie, but I'm going to give you an opportunity to look at this question by leaving this example here up for you. The others who were here last week can look back at it to see if they can do the question again without looking back. And that's the thing. You see, when you do past paper questions, sometimes you may see me repeat a past paper question, because it's not just for you to do the past paper question one time and say, yeah, you're good. It's for you to do it several times to make sure that you can do the question on your own. So those two who are here, who were here last time, see if you can do this without looking back. Laurie, you are the only one allowed to look back at this. So look at this. I give you about 3 minutes for you to do that, and we can do some more questions. All right, go. I'm here listening to you.
Sir?
Mr. Chan? Sir?
Yes, I'm hearing you.
So it's Kerry. Good morning.
Good morning, Bobby. Come on. Laurie gave us the thing. She told us that you were still in bed and your husband was making breakfast and that you couldn't get out of bed because you wanted to be served all the wonderful stuff in bed. So as soon as all of that is done, then you'll come to class. So we got the message.
I'm sure Laurie didn't tell you that, sir. I'm using my phone because I'm not
Okay.
able to log on the laptop because of this internet thing. So I had to add some data and log on. Sir, have you started teaching anything or would you be sending the recordings?
It's really a review that we have been doing, Kerry, and not
Okay.
really teaching because Laurie wasn't here. So it's just a review so that Donny and you and Colin can just catch up on what it is that we did. So I have not done anything new since we've met this morning.
Okay, sir. Thanks.
Bless you. All right. So Kerry, not Kerry, Laurie, I have posted the stuff here. Are you okay with this so far? Because what I'm going to do is to project this other one here that I want you all to do. I know the others would have done it already, but just project this one here. So continue working for me.
Sir, if you're talking, I'm not hearing.
No, man, I'm not talking. What I'm doing is just doing a question for you while you are doing it, because I recognize I never did it. So I'm not talking.
Okay, sir.
All right. Now, all of you, because I think I gave this as a classwork last time based on what I sent out. So all of you should now be able to answer what is happening here. But in particular, Laurie, were you able to get 2 to the negative 2 right here for this one that we did, that I did? All right. Anybody hearing me?
Yes, sir, you're hearing.
Okay. So were you able to get, and I know I gave you this as homework last time, Donnie. Were you able to get 2 to the negative 2?
Yes, sir.
All right. So remember, I said to you earlier that as math people, we are always positive thinking people. So we're going to write our answer as a positive index. So what we're doing, instead of writing 2 to the negative 2, we're going to write our answer as 1 over 2 to the positive 2. Calling it, no, Denise, she's hearing. Calling it, Kerry, Laurie, you hearing? I want to make sure that you're following.
Yes, sir.
Okay, good. So, so that's how we end up with that answer. Now, if you look at the fourth one, it says 81. It says 81 over 3 to the 0 times 3 to the negative 3. Now, remember, the base here in the denominator is 3, so is this base here 3. And the law that says when I'm multiplying and the bases are the same, I'm adding my powers. So it's going to be 0 plus 3, which is equal to 3. All right? But 81 can be written as 3 to the 4th. 3 times 3 is 9 times 3 is 27, and 27 times 3 is 81. So I'm converting this 81 into 3 to the 4th. Then, sir, oh, you said that's something from me can see. Right, not. It will come with practice, and the more of these questions that you're doing, which is why I'm saying to you, we have to be working quite a number of past papers. The more questions you work using or doing this will give you a better understanding and grasp of it. So if I ask you, how do you write 32 as an index, you can write off the bat, say 2 to the 5th. If I say, how can you write 8 as an index, you can write off the bat, say 2 to the 3rd. All right. So you will get there, but you need to be practicing. So I'm going to have 3 to the 4th, which is here. And then because I'm adding this, 0 plus 3 is going to be 3. I'm going to end up with 3 to the 3rd power here. And then the law says, when I'm dividing and the bases are the same, I'm going to be subtracting the numerator power from the denominator power. So it's 3 to the 4 minus 3, and that is going to be equal to 3 to the 1st, which is the same thing as 3. Which is the same thing as 3. Are there any questions so far? Hello, somebody?
No, sir.
Okay, well, thanks. So this is 3 to the 1st, which is the same thing as 3. I'm just trying to make this just trying to make that self-explanatory so that when you see it, you can understand. And then this other one now says 2 to the 4th times 16. Wow. 16. If 2 to the 3rd is 8, sir, because I just said that. When I multiply 8 by another 2, I'm going to get 16. Oh, so 16, sir, is 2 to the 4th. Very good. So I'm converting this to 2 to the 4th. And I'm also converting 9 as 3 squares. Then, sir, let me ask you a question. So what if they give you a question and you can't convert it into an index? How you do it? That will be a non-question. So they will never ever give you a question that you can't convert as an index. Like the might give you 11 to break down. They won't do that because what they're testing at this point in time is your use of the laws of indices. So if the number in and of itself can't be broken up as an index, so to speak, they won't give it to you, right? So, and you will see in this very question, you will see what I'm talking about. Let's go. So this 9 can be broken up as 3 squares. So see here I have 3 squares. But sir, what is happening here? I don't know. The law says when I'm multiplying and the bases are the same, we're going to be adding 1 power. So you may not see what is going to happen with the question, but we're going to word the question nonetheless. 2 to the 4th times 2 to the 4th is going to become 2 to the 8th. See it right here, so 2 to the 4 plus 4, 2 to the 8th. And 3 squares times 3 squares is going to be equal to 3 to the 4th because it's 3 to the 2 plus 2. What do I do right here when I get this 2 to the 8 over 3 to the 4th?
It's subtract.
I said, no, the bases are not the same. The bases are not the same. The bases are not the same.
Oh, sorry, I thought it wasn't two.
Right. But no, but Donnie, that's fine. I'm happy you said it because I want you people to recognize that. So I'm happy you said it. All right, let me just write this as, let me just break this one a little bit more. I'm going to break that one a little bit more for you. I want to put it there because I was working the question, and so I'm breaking it down a little bit more for you. Oh no, that's not what I wanted. I want this one, so I copy this one and paste it right here. Sometimes we have to word the question backwards. But of course it will come with you will have to just work it sometimes backwards. And then you're going to say to me, sir, you have to do all of that. It's just difficult. Sometimes it can be very troublesome in setting these papers, but I'm just showing you what is also possible in simplifying this answer a little bit further than how we had it. All right, so look at what is happening here now. So what I have in blue is not the final answer because it can be broken down a little bit more. So look at what I did. This 8, do you recognize that 2 squares raised to the 4th power is the same thing as 2 to the 8? Let me answer that question that way first. Hello, somebody?
Yes, sir.
All right, very good.
We got that a while ago.
This again, Kerry?
Sir, you're not going to use the 4 on the bottom of the 2 to the 4?
I'm coming to you. I'm coming to you, Kerry. I'm coming to that one. I'm coming to that one. So I am breaking up this 8 as 2 times 4. So why 2 times 4 in particular? Because I know that I have a 4 down here. So in answering your question now, Kerry, is that because there's a 4 in the denominator, in the numerator as a power, and a 4 in the denominator as a power. You see, when I put everything in parentheses, and I have this 4 up here, so this 4 covers these 2 squares, and this 4 also covers this 3 to the this 3 down here. So this power governs both terms in the numerator and the denominator. Does that answer your question, Kerry?
So I didn't hear you clearly, sorry.
Now I'm saying to you, I broke this 8 up as 2 times 4. Why, sir? Because this 4 is the same 4 in the denominator here. So I'm going to combine all of these fractions and then just make 1 raised to the 4th power. Because when I raise this to the 4th power, it means that this term, this 4th power, governs the numerator, and this 4th power governs the denominator. So when I put it in parentheses and raise it to the 4th power, it governs both this one and that one. Does that answer your question?
Okay.
Good job. All right. Now, when you're doing indices, it's not necessarily only numbers that them deal with. Them deal with some variables also. So guess what? I am being troublesome. Being troublesome by giving you one of those questions where the base is not a number, like all the other questions, the bases were numbers. I'm giving you one where the base is not a number, and you're all seeing this well. The ones I may have copied this one to the work of the others. So I'm going to give you about 5 minutes to try and work this one for me. 5 minutes to try and work that one. I have the solution, so just try. I'm not asking you to get the question right. The class is not about getting the question right. The class is about trying, so it is that you can see what is happening. All right, so I'll give you 5 minutes to see if you can get that done for me.
Them said the technician aware.
Are we okay? Just try and apply the laws of indices, and you should find. Are we okay? Or are things going? Remember, you have to talk to me so that I can know that you are truly following what is happening. Right? Hello? Anybody? Somebody? How is it going? I need somebody to talk to me, please. Asking for work
Sir,
number.
what were you saying, sir? I was actually working. I heard you said something, but I was working. So what were you saying?
No man, I don't know how I get these numbers. My number is wrong. Because that is 3 and that is 4, that is 5. This has to be 6. I want you to work number 6 for me. But I want you to work number 6 for me just to get an idea as to where you are and how we can maneuver the question with the base not being a number. All the questions I gave you so far, the bases were all numbers. In this case, the bases are not numbers, they are x's. So I want to see how well you work with that question. So I was checking to see how far you are with the solution to that question. Okay, so that is more than enough time. Have you completed the work for number 6? Have you completed the work for number 6? Come on, guys. There are only 3 of us in the class. I should be hearing
Yes,
some
sir,
responses.
completed.
All right, so
Sir?
look at it. Yeah, I'm hearing you. You hearing me?
Yes, sir. I said I completed it.
All right. Was that the answer you got? X to the 19 over 2 or 38 over 2?
19 over 2. Yes, that was the
Yeah,
answer.
that's
But
what you got?
I was completely unsure of it because I did 2 other. So I was like, seriously? That's what,
Yeah, man. So that's what you got, right?
yeah, I got that first.
All right, good. So watch this now. Watch this now. So that's supposed to be 6. That means this is 7. Watch this now. I'm giving you a question that is going to be very difficult. This one is, it's not that it's not solvable, but this one is going to require you putting on the thinking cap. You're trying to get through all the laws that we would have done before. So I'm going to ask you to try looking at it, take into consideration all that I would have said to you. Afterwards, I will go through it with you. I've already done the question. I just want you to look at it to see if you're fully understanding. All right, start.
Question. Why didn't you put the x and -1/2 over 1? Because I was actually doing that in one of the attempts.
No, because what I'm actually doing is finding the LCM of all of that copy. I'm actually doing something here too. Sorry. All right. So look at what I did. And I'm multiplying and the basis are the same. I'm adding my powers. So it's going to become 20 minus 1/2 because I'm adding the powers, which is right here. This sign means equivalent. So this is not going to be equivalent to me finding the LCM. It is going to be, all right, so let me do something else here. I want to make sure that I give you the fullest explanation if I possibly can. Here on it, please. Okay, so look at what is happening now. So when I'm multiplying and the bases are the same, what I'm doing is adding my powers. So this becomes 20 minus 1/2, which is this here, which is equivalent to 20 over 1 minus 1/2, because my 20, this 20 out here, can be written as 20 over 1, because it's really a change in the fraction. So when I have 20 over 1 minus 1/2, then I'm going to find the LCM. The LCM is only 2. See there? And then 1 into 2 goes 2 times, and 2 times 20 is 40. And 2 into 2 goes 1 time, and 1 times -1 is -1. And 40 minus 1 is 39 over 2, which is the same thing as 19.5. Then, sir, what if I left my answer as x to the 39 over 2? Would I be correct? I would give it the full marks. I honestly would give it the full marks, but I also want you to recognize that it's the same thing as me breaking it down to to say into slowest term, simplified term. Danny, are you okay with this now? Is it better understood?
Yes, sir.
Good job. All right, so let me go back to this one here now. The one not troubling us if you don't eat breakfast yet, you don't know how you're gonna manage. I'm sure that you don't eat breakfast yet. Got the house is silent. So let's try this one. I give you 5 minutes.
So I drank some tea. I drank some
Ja-
tea.
All right, then so you're well ready then. Because I have some tea myself. All right, let's go. Give it 5 minutes and then we stop and see where we are. Where's Lori? Where is Holiday? Come on.
Sir, I am here. Just having a headache. So I'm gonna look some tea, just 5 minutes.
All right, cool. checking in to see how it's going. Danny, how is it going?
So I'm finished. I'm just checking over.
As soon as you finish checking over, let me know. Calling it, still waiting on you. Laurie, I hope you're sipping a tea by now. You can just look at the moment there and the moment I put the head on the moment of pressure, just walk and spot up on and drink the tea. And incidentally, I hope it's not my math that has caused your headache.
Finish. Sir.
Good job. All right, I'm going to project. You're going to look at it. What I try to do is to be very detailed in the stuff. So it could be done in a few more lines, lesser lines, but I was trying to be a little detailed. Let me just reduce this a little bit so I can project all of it at once. There you go. One more time. Last time. Look at it. I'll give you a couple minutes just to look through. We're not seeing. I can do the explanation. Where's the Danny? Talk to me. You see what is happening?
Yes, sir. Sir, what I did wrong was that I divided everything by the
Aha. All right, so let me just go through for those of you who didn't try and just walk you through the process. Remember, sir says anything that is in the sleeve of the square root sign is going to be raised to everything, it's going to be reciprocated first and raised to everything that is under here. Remember that? So what I did here was to separate these to show you that 3a to the 4th times 3a to the 5th are the same thing. The same thing. So I can separate it like that and I have three different terms, 1, 2, 3. So it can be separated like that. What I could also do, is to show you that all of these will be raised to the 1/3. So I'm going to end up with a to the 4/3, which is what I ended up here with, and b to the 1/3, and b over 3, which is what I ended up here with. So what I'm doing here is just showing you the separation here so that you can use the number 6 one that we did, the nth root of e to the m. And Laurie asked about the nth root of e to the m. So the nth root of e to the m, is it here? No, it's not there. But the nth root of e to the m is going to be a to the 4th raised to the 1/3. The nth root of e to the m, here it is. The nth root of e to the m. Copy. Go all the way down to number. Hold on, wait a minute. Yeah, that is 7. That has to be. What is wrong with my numbering? Example 1, 2, 3, 4, 5, 6, 7, 8. That is 9. And this is 10. Somebody can't find. Okay, I know what I did. I need to add some questions. 11. And this is 12. I don't want to confuse you when I send you the document in the eventually. That's 13. Okay. Right, so I just copied some things. I'm going to paste it. All right, so I have to paste it out here first, and then do something with it. But I also need to do something else. I need to cut this. And then I need to place it back. And then I need to close it there. And then I need to say RECA. All right, so I want to recall the cube root of a to the 4th. The cube root of a to the 4th is going to be like this. So it's going to become a to the 4th over 3. See here? A to the 4 over 3. So that's what that becomes. And the cube root of 3 of b to the 5th then become b to the 5th over 3. B to the 5th over 3. So all of this here is just for me doing the sort of explanation that is happening here. And I can do it several ways. So you see, this way is showing you that. Okay, and then when we get to this here, this b to the 1/3 over a remains. And notice I carry back b to the 1/3 over a, 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 because I was simplifying this first. So my simplification comes all the way down here. Now that I reach here, I'm going to multiply, or not multiply. This law says a to the, if I have a to the positive m in the denominator, if I take it to the numerator, it becomes a to the negative m. So I'm going to take this recall right here. I'm going to take that recall right here, and I'm going to put the recall up here. Okay, I need to do something with this one, so you can follow exactly where the recall is. I'm going to cut it. No, cut. Yes. No. Undo. All right. So look at what does that mean here. So since I just titled the document a little bit, let me just explain to you what it is that I'm doing again. So this piece here, I am breaking up into the cube root of a to the fourth times the cube root of a to the fifth, right here. And then the cube root of a to the fourth times the cube root of a to the fifth. I'm gonna have, could have it as a to the 1 over, I'm showing it two options. I can have it as a to the times raised to the 1/3, because I'm reciprocating here. B to the fifth raised to the 1/3, because I'm reciprocating. And when I do that, I'm going to get a to the 4/3 right here and b to the 5/3 right here. Or I can just move directly from here, which is here, into here. Whichever way you take it is the same thing. But the point I'm making though is that b to the 1/3 over a remains the same until I reach here. You notice I'm saying a is the same thing as a to the first, as we would have seen. Now what I'm doing is converting this a to the first from the denominator to the numerator. Why, sir? Because I want to make life much easier, because I recognize I have an a here. So when I multiply by, when I take it to the numerator, it becomes a to the -1. Why, sir? Because it was a to the +1. So see here, if it is a negative in the denominator, when it becomes a positive over here. Or if it's a positive in the denominator, it becomes a negative over here. And then now I've been multiplying all of these. So rearranging, that's what I'm doing right here, rearranging, rearranging. So I'm rearranging to give me now a to the 4/3 times this a to the -1 times b to the 5/3 times b to the 1/3. Now when I'm multiplying and the bases are the same, I'm adding my powers. So it becomes 4/3 -1 right here. So, and again, when I'm multiplying and the bases are the same, I'm adding the powers. So it becomes 5/3 -1/3. See it right here. So, and 4/3 -1/3 is going to be a third. 4/3 is 1 and 1/3, and I subtract 1 from it, I'm left with a third. Let me show you a trick right here. When you're adding two fractions and the denominator is the same or are the same, you just add the numerator and put by the denominator. So 5 plus 1 is 6, and 6 over 3 is going to be 2, and that will technically be my final answer. All right, so just take a minute or two again. I'll soon be wrapping up. I may just do one or two more questions, or maybe I just do one other question, and then which is another form that will take us in, and then I leave those for you for homework. I won't necessarily, I can send those, and then I need to generate somewhere. Oh, see, we're almost coming to the end of in the season. Oh my goodness, look here. That's the end of what I have there for you with the document. I'm going to send you, I'm going to do one more question with you. Since I'm at number 7, I'm going to go through 8 with you and then leave it to the 9, 10, 11, 12, 13, and then I have some do now exercise. And then I will set some classwork for you for next time around. All right. Take a minute or two just to look back at that one, and then I do one other, and then we can call it a morning. All right, so I'm going to move on to the last question. You don't need to necessarily write because I'm going to send this off. Words like, oh, Lori, not feeling so hottish. I'm going to move on to question 8 and then we'll call it a morning. All right, can you start working for me, please? Are we okay?
Yes, sir.
Sir?
Right here waiting on you.
Thanks for waiting.
Come on. Feeling better now?
Yes, sir, it's coming on.
Nice. Morning, Richard. How are you? Hey, morning. How you doing? All right, cool. Come on, cool. All right then. So let us see how we can proceed with this question. Has anybody completed this question?
Yes, sir.
What is your answer?
I got 1/49.
1/who?
49. 4
1
raised
over
to the 9th.
one
The
raised to
9th.
one. Or 1 raised or 4 raised to the 9th power.
Yes.
All right, let us check to see where you are with this. Look at that. I'm sorry. Oops, sorry. Oopsie. Sorry. Look to see where it is that you would have made an error, and then tell me to follow what is happening. I'm going to be setting quite a bit of questions for you guys on this, and send off in the meantime.
So instead of the 2 to the 6th, I use 4 to the 3rd power.
Okay, and if you use 4 to the 3rd power, you're going to end up with.
I still should get the same answer. Like
Yeah, man. Because if you use 4 to the 3rd, you're going to end up with 4 to the -1. let me work it and show you what I'm talking about. Well,
Okay, sir.
I'm happy that you recognize that 6 to 4 can also be written as 4 to the third. Copy. Oh, come on, don't do this to me now. All right, so you said that it's 4 to the third. And then would be 4 times 4 times 4 is 4 to the third. Right, and then this is going to be 4 to the 3 times, right? Is that, and then change this to 4, and then this is going to now change that to 4, and change that to 3, and change that to -1. To put this as answer, and change it as 2 times 2. Oh no, don't do that. Look at that from please for me.
Sir, I work out everything, work out everything and had the 3/3 and still put 4 -9.
If,
So
oh,
I did
okay,
everything
okay,
right,
yeah, yeah,
but
yeah,
I
yeah, yeah,
just,
yeah, 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 yeah. No, no, I can understand how you get the -9 because you multiply the -3 by the 3.
yes, sir, but
Yeah, yeah,
even
yeah,
though
yeah,
when
yeah.
I multiplied and got 3/3, is it
Mm-hmm.
the fact that I didn't cancel it down and put 1? Probably that's why I'm just like put 9
Yeah. No,
instead.
no, I can understand how you get it 3/3. 4 to the -9. Yeah, yeah. So okay, I'm a little bit more at ease now because I was wondering, okay, I was wondering how you end up getting 4 to the -9, but I see clear as mud, clear as mud. And I will just show you, and you can tell me if what it is that I'm saying is indeed correct. So that's going to be 2 to the -2. Let me just do this. I see it, honey. And I'm happy you made a mistake now so that you won't make it again. But I see exactly what it is that you did. Let me just save this. So what you did here, you got this and you got up to this point. True or false?
Yes, sir.
Right. I see you got this up to this point, but the mistake you made was to say -3 times 3 is going to be -9. So you end up with a
Yes,
4 to
sir.
the, you ended up with a 4 to the -9. And because you end up with 4 to the -9, you reciprocated and got 1/4 to the +9, don't?
Yes, sir.
All right. Let me tell you what is going to happen. So for today, because you made this big mistake, you had tea already. When you're going to eat your breakfast, it's not going to taste as nice because you made this unforgivable mistake. But guess what? If when the breakfast don't taste so nice, and you understand the mistake that you made, your Saturday dinner will taste even superb, right? But guess what
Yes,
happened
sir.
now? So I'm confident that you got up to this point, right? I know you don't get a couple marks for this. I see where you made the mistake right here. And then with that mistake that you made right here, the other steps, having made a mistake right here, the other steps would have been correct, but because you made a mistake here, these other steps will be wrong. So if the question carried 5 marks, you could get as many as 3 marks, between 2 and 3 marks out of 5. So you want to get 0 for the question. So it is important, again, guys, to show your working out. Always very important to show your working out. All right. So we're going to end here. We started class at about 8:35 when we really started. So I really wanted to give you guys 2 hours. I would have given you 2.5 hours this morning. And just I'm going to send you the notes so you don't have to worry about it. And some extra questions. I won't send it immediately because I was going to take a little break later on a little bit and write some questions, type them, send them off to you. I may not do the answers. We'll together with the answers when next we meet. So just to say to you again, forgive me for the delay in really moving for the 4 hours, but you recognize I can't carry a class with 3 students. Well, 4, because Kerry is part of us. I keep seeing this Amanda person logging on. She did it like about 3 times and then log off. I will continue just meeting with you to do some stuff, but if you recognize, watch me. If you recognize 1, 2, and these are 2 pages of examples, 3 pages of examples, 4 pages. So it means then that I would have completed indices with you. I would have completed indices with you. All we're doing is just questions on indices. All we're doing is just questions. So pretty much we're getting there. I would have been finished already, but we're getting there. So what I'm going to do is to give you this document, add a few more questions so it is that you can practice within the week. You know, matter of fact, here what I'm going to do. I'm going to add 6 questions, 1 a day tablet, 1 for Monday, 1 for Tuesday, Wednesday, Thursday, Friday, and then you're going to do 1 today. So when I send you this stuff, you'll do 1 Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, yeah, whatever. So I'm going to give you 1 a day. All right. So and if you do that, you should be fine. All right. If there are no questions for me, we can have a wonderful rest of the morning into afternoon. Are there any questions?
No, sir, none from me.
All right, then. I know. Laurie, want to take your headache, calling it. Don't know what happened to you today, but I know you were talking to me in the chat, or talking to us in the chat. So have a good one. We'll talk here, guys.
Yes, sir.
Right.
Yes, sir.